is Michelle Key, and I'm a senior at Chadwick School who has an interest in pursuing marine biology slash science with some kind of climate change minor. And my target is to become some kind of like marine veterinarian when I'm older. First question is like, what do you specialize in marine biology?
So, as someone who works in marine bio, I have a little bit of a weird background. So, my name is Joshua Nooij. I am a environmental scientist and marine scientist in at Northeastern University. I am originally from the Netherlands. I studied environmental science there and philosophy. I did a double degree. And while there, I did two minors, one in Australian biology when I lived in Australia, and one in evolutionary biology. And during my undergraduate degrees and the first part of my master's degree, I actually really focused on terrestrial biology. So I did a bunch of work on restoration of plants and reintroduction of some dune lily species. But when I moved to the US, I kind of coincidentally got really close to a professor at Northeastern University who focuses on marine biology and marine communication. So I accidentally enrolled into marine biology. So unlike you, it was never my goal to be a marine biologist. I wanted to be a or an environmental scientist, and kind of coincidentally fell into marine research. So it's uh, it's a bit of a different study path. Um, what I'm doing right now is I work a lot in science communication. So I have done a bunch of like actual science. Like I said, I did reintroduction. We did core samples, plant samples. Is when you go out in the field and actually take samples of plant species or of course or soil samples or water samples and research those back in the lab. I've done that in the past. Right now, what I have focused on for the past half a year, um, is education, science education. We're trying to create a educational game for middle school students to make them understand food webs in marine ecosystems better and to make them understand the mathematics behind marine ecosystems, without actually having to delve deeply into the complex mathematics and complex mathematical models. In the summer, over the summer of 2021, I worked with the Rhode Island Department of Environmental Management in shellfish reintroduction. So it's kind of complicated what I specialize in. I've done a bunch of different stuff. But I would say what I tend to specialize in is reintroduction and science communication. So that's what I've done the most of.
That's really cool that you're making an app for middle schools to understand. Like, I didn't know there were mathematics behind like food webs. I just always thought like I the bigger thing eats the smaller things, and it starts with the plants. And then
I know. Everything in biology is more complicated than it seems at first glance.
and what are some like amazing things that like, you've seen slash discovered when you're out on the field?
So, like I said, my background isn't necessarily in marine science. So if you're gonna interview more people, you're gonna hear a bunch of cool stuff. So relating it back to marine science, when I lived in Australia, I had the great opportunity to go snorkeling and diving in Sydney Harbour. And as a research project, we had to count fish. So we did like a fish index, fish stock index. So I had the great opportunity to go diving there and just see the cool fish that you have in the Australian waters and count the type of snappers, count the type of flounders, etc., that you have there. So that was really, really cool. Um, what I think the great thing about research in general, and this is not necessarily marine bio, is that the people that work in academia, especially in the hard sciences, they're generally people that are really, really passionate about their topics. So if you find a professor or a scientist that is doing the same thing over and over again, such as when I was working on the shellfish reintroduction topic on the shellfish reintroduction project, I ended up interviewing a couple people that were working in shellfish biology and shellfish reintroduction for the past 60 years. And it was just really cool to see people that were so passionate that they were able to do the same thing or focus on the same topic 60 years, and they could tell you the whole entire history of shellfish reintroduction in New York, in Rhode Island, in Massachusetts, which was really cool.
Well, that's amazing. Like, since you like said like you lived in like the Netherlands and like then went to like Australia to study and now like the US, like how's like the different like environments and like ecosystems like you've seen like different or like similar?
So obviously there's a bunch of differences, right? So I'm going to complicate into what the exact differences are. Um, I think Australia just I don't know if you've heard about the Wallace line. I don't know if the listeners of your podcast have learned about the Wallace line already, but
Ooh.
there's a very large difference between the type of species that you'll find in Australia, Indonesia, that area, and the Western world. So Europe and North America. It's largely because of those two supercontinents, so Laurasia and Gondwana, that then separately evolved for a very, very long time. But in Australia, you find a bunch of there's a lot of endemic um, amphibians and lizards, amphibians and reptiles in the Australian area that you don't see anywhere else. So endemic, it means that it doesn't occur anywhere else but Australia or the Oceania. So that's really cool. In the Netherlands, I think what's kind of special about the Netherlands is that it's small. The Netherlands is a very small country, which means and it's known for being a wet country. So the Netherlands means the lowlands. So there's just a lot of water. And what the Netherlands is most known for is for basically creating land out of water. So we have something that we call polderen, and that means that you just pump water out of lakes to create more land. So there's a whole province in the Netherlands that's basically just a lake that people make not lake anymore. So the species that you find surrounding a bouldered area is different than the species that you'll find in other lakes, just because of the significant changes that humans have done in the area. Now in the US, what I've done here is very specialized work. So what I thought was really cool in the US is that that is really possible. So like I said, I focus specifically on bay scallops, which is a specific type of shellfish in Rhode Island. Um, but what's really good in the US is that you have this is something that scientists are going to have to work with more and more in the future. Is that in the US you have very strict policies for a bunch of stuff that you have to follow when you're a scientist, such as the Endangered Species Act. So, fun story: when I was working with Rhode Island, we were doing a fish index. So we were trying to catch fish and see how many fish were everywhere. And we ended up catching a couple of endangered sturgeons
Oh no.
accidentally, and they died because that's what happened when you catch a fish. So that was we ended up having a couple of very difficult meetings because we were debating whether we should continue the stock because we wanted to know how much fish were there and what type of fish were there, but at the same time we didn't want to catch more sturgeons. So that was really cool in the US.
Oh wow. Yeah, like I heard like there's only like a couple like sturgeon species left in the world, which I find interesting. Like I feel like there's like not that many.
Hmm.
And then as we're currently living through a climate crisis, what are some of the major effects of climate change on your specific area of work?
So for me, like I said, I'm an environmental scientist first. I kind of fell into marine science.
Mhm.
So for me, the climate change crisis is kind of impacting every single part of my work. Um, because even in marine science, that's what I tend to focus on. The reintroduction, the bay scallops kind of died out because of overfishing, but also because of algal blooms that were caused by nutrient loading and by increased water temperatures. So those are things that I'm focused on basically every day in my work. Um, what is kind of cool, and what I guess is a positive of it being a climate crisis, is that more and more people are becoming aware of the climate crisis. So this, just bring it back to what I'm doing right now. This game that we're trying to create is trying to focus on or trying to use temperature gradients. So see what different ecosystem looks like, what different ecosystems look like with different temperature uh, fluctuations. So if obviously if the temperature is higher in an ocean, then different species of fish will survive there, and these fish will have to be adapted to the temperature. So that's kind of what we're trying to teach these people. Um, what's difficult is that you have this is that climate change is weirdly enough or sadly enough still a very controversial topic, so that you'll always run into people that either don't believe in it or question your validity of your science or make counter arguments that to me don't make a lot of sense. But you're still going to have to enter into conversation with these people, because if you just ignore them, I think there's something along the line of 18% of Americans are climate skeptic, or that doesn't mean that they don't believe in climate change. That means that they aren't sure whether they believe the science, and that's a relatively large amount of people. So we're going to have to enter into conversation with these people if we want climate policy to be where we want it to be, and that's, I think, the responsibility of all scientists everywhere now. But that's, I mean, I'm an environmental scientist. I'm biased on this topic, so
Yeah, like I think in like in middle school, I think I had like I met him like an adult, and like I think he's like in looked like he was like 60s maybe. He was like did not believe in climate change, and I was like obsessed with like learning about like coral reefs and the fact of like ocean acidification and like the climate change entirely. And I was like, what are you talking about? It's like clearly happening, and we're like, it's still snowing, it's still getting cold, and it's still getting hot. I'm just like,
I
well,
know, I
it's
know.
supposed
People,
to be stronger.
that's exactly the problem, right? People conflate climate and weather, and that makes them confused. Because I mean, you have that I think 2016, the speech by ex-president Donald Trump, where he said it's now 20 degrees outside. I need some climate change. I need global warming. Where is
Yeah,
global warming? And that's just people not understanding what climate means. And that's exactly why something that like science communication is increasingly important, because science has been such a kind of closed off subject that only people that have studied science will understand science fully. And what the goal is now is for everyone to have at least a basic understanding of science. This is kind of off topic. It's a bit tangentially related to what you asked me, but it's something that I've been working on a lot. So, but yeah, it's silly that we've known about climate change since the '60s, since Silent Spring, Rachel Carson, and still people don't understand what we mean when we say climate change. So
yeah, it's like no, it's like supposed to make it more extreme, but like it's supposed to get colder when it's cold, and it's supposed to get hotter when it's hot. Not like the
yeah,
fact that it's like hot 24/7. It's just
yeah. Plus, we're talking even if because we're talking about global warming, right? So the planet is warming completely, but it's average global temperature. So we're not talking about that it's gonna be a degree and a half warmer every day. We're talking about that on hot days, like in the summer, it's gonna be maybe 3 or 4 or 5 degrees warmer, which makes it over a year average 1.5 degrees per annually warmer. So it's those kind of things. It's that type of mathematics that people just don't understand, because it's over such long time scales. People see snow, so it's snowing in Boston right now where I live. It's snowing in Boston right now, and people see the snow, see that it's 25 degrees Fahrenheit outside, and think, well, it's really cold, so climate change must not be happening. But that's not what we mean when we say climate change, which is a very, yeah. It's hard to because climate means weather to a lot of people, but it's not the same thing.
yeah. And then what? Also, then, how have your teamwork skills been challenged in your line of work?
I mean, for because you're a senior in high school, I assume, right? That's what you said.
Yeah,
Yeah. So you're gonna go to college. Well, I assume that your goal is to go to college.
yeah,
And when you go to college, you're gonna do a bunch of group projects, and those group projects are more often than not gonna be really difficult, because group work is often very difficult because you have people that want to lead, people that don't want to lead, and if you have more than one person that wants to lead your group, it's gonna cause problems. If you have know people that want to lead in your group, it's going to cause problems. If you have a bunch of lazy people in your group, it's going to cause problems, etc., etc. Doing collaborations is always difficult. That's just the fact of the matter, right? But if you're able to um, facilitate collaboration, then if you are with a group of people that are all passionate about what they're doing, your project is always going to be anti-Gestaltian, right? It's going to be more than the sum of its parts. So right now, I'm working the project that I keep talking about that game. We're working with a group of like 10 people from game design, from media, from data physicalization. So that's really like social science and design. And then we have computer science to create the game. Actually, we have psychology to see if it's actually working. We have people from marine science or people from environmental science that are doing the mathematics behind the models. So nobody in science knows everything, right? I and another project that I'm now working on is a collaboration between someone between me, so from environmental marine science, and a PhD candidate from the psychology department and a professor from the public policy department. And by us working together, we are able to all bring our skills to the table. But it does require some, because people, when I was in high school, I assumed that professors were the smartest people alive, right? And in a way, that's true, because professors, doctors, people that have their PhD, people that have worked in the field for a long time know a lot of stuff but they know a lot of stuff mainly about their own topic. So if I'm working with someone that is in the psychology department, then I tend to assume, and this is this kind of an egocentric bias, I tend to assume that they also know about the stuff that I'm working on, but they might not. So what's difficult is finding that balance of being productive and working together, but not assuming that people know exactly what you know, because you don't know exactly what they know either. Like I said, I'm working with people from the psychology department. They know significantly more about cognitive and behavioral stuff than I do, but I know significantly more about marine environmental science than they do. And if we understand that and we kind of trust each other in that way, then you can create a project that's better than if you were to do it by yourself. So, and on a positive note, on group work.
Okay, and then for the final question, I'm assuming it's gonna be like some kind of shellfish, but like, what is your favorite marine animal?
Well, it's actually, it depends on what you mean with marine, right? If we're talking about fish, I'm not 100% sure. Like I said, I was a terrestrial biologist for the most part of my career. So I think my favorite marine animal is probably the marine otter, because I really like mustelids. Um, Unlike a lot of other academia people, I have a lot of tattoos. So I have a tattoo of a mink, which is a mustelid, on my thigh. I have a tattoo of a platypus on my thigh. So a penguin, penguins. I think penguins are my favorite marine animal, actually, because I'm a bird person. If I could, I would move to Antarctica for half a year. So I think that's my answer. Final
I love
answers.
minks. They're so cute. They're like little ferocious hunters, but they're like
I know, right? They take down prey that's like 10 times their size at least.
they're
It's
so
crazy.
cute. I watched this guy on YouTube who like uses minks to like catch rats and like
Hmm.
that's how he gets rid of rat infestations. And I just think they're just really cool hunters because
Yeah,
they're
I mean, like weasels and badger, no badgers, but honey badgers can take down ungulates. So it's like deer and elk and stuff. So they're ferocious hunters. They're really cool. So
okay. Well, thank you for joining me, and we're gonna end the interview here. So I'll stop it here.
Have the strangest feeling to know what to believe in. Cause every time you touch me, I can't control